we'll solve the fourth problem. Okay. This problem, what is the question is, calculate the output voltage produced by the DAC. Okay, you are supposed to calculate the output voltage produced by the DAC when the output range is between 0 to 10 volts. Okay, even here also they have given a scale, the starting scale as well as the end scale. You have to consider the final voltage. Okay, that whatever I have explained in the previous problem, the same concept. For the binary number 1 0, it is a binary number, it is 1, it is not 10, it is 1 0. So that's why they have written a base as 2. Even if they are not writing and if they are just giving 2-bit DAC, means you should be in a position to understand it is a 1 0, it is not 10, because they have already given it is a binary number. Okay, so now so they have given a two data. First data is 1 0 and the second data is a 0 0 or 1 1. Okay, so by taking these two data, okay, we have to solve the V0 separately. First, I hope you are able to get the value. I mean, you are able to see the formula here. So V0 is equals to minus. We are not considering the minus sign because the output voltage we are assuming it as a positive voltage. Okay, we are not assuming minus. Okay, in the derivation you will be getting it as a minus sign. But during solving the problem, we are not considering this minus. We are considering the modulus. Okay, the voltage will never be minus. So therefore, we have to consider it as a positive voltage. So okay. So V0 is equals to, okay, what is VI? Reference voltage. That is 10 volts. Okay, you should not consider it as 0 because it is the starting voltage, and the maximum voltage you have to consider that is at 10 volts. Okay, I am directly writing, I am directly substituting. Now, what is B1 and what is B2? So this is B1 and this is B2. Don't assume that this as B1 and this as B2. Okay, so this one is there, no, that is B1 and this is B2. Okay, so 1 into 2 to the power of minus 1 also you can write, or you can also write it as divided by 2. Okay, because we know that 1 by 2 you can write it as 2 to the power of minus 1, right? Yes or no? So therefore in the formula 2 to the power of minus 1 badlu, I am taking 2 to the power of minus 1 to the denominator. Right? Next, plus what is B2? B2 is 0. So 0 into 1 divided by, instead of writing 2 to the power of minus 2, I will write it as 2 to the power of 2 here. Okay. So anyway, this will be tending to 0 because anything multiplied with 0 is 0. So therefore this will be tending to 0. Now what will be the answer of V0? For the first part, V0 is equals to 10 divided by 2. That is nothing but V0 is equals to 5 volts. Okay, V0 is equals to 5 volts. Next, this is the answer for the part B. Coming to part A, coming to part B, how many bits are there? 0 0 1 1, right? So let me write down the same, let me use the same formula. So V0 is equals to, what is VR? Again we have to consider the 10 volts itself. So 10 divided by, what is V1? V1 is equals to 0 into 1 by 2 plus 0 into B2 is equals to 0, right? So therefore 0 into 1 by 2 plus B3 is equals to 1. So 1 into 1 by 2 cube plus B4 is equals to 1 into 1 by 2 to the power of 4. Okay, and since you are multiplying with 0 here, this and this tends to 0. So once these two tends to 0, what will the value now? So V0 is equals to 10 into, okay, 1 divided by 2 cube is nothing but 1 by 8 plus 1 by 2 to the power of 4 is nothing but 1 by 16. Okay, what will be the value now? Use the calci and keep the answer. So it is nothing but 1.875 volts. For the any problem, you have to keep the answer with the units. Then only you will be getting the marks. Okay, and if you are don't forget to highlight the final answer. Okay, You can write a 2 lines or you can keep in the square box. I hope you are clear, and you can take a small assignment. So I am giving the third part 11011. Okay, I hope you can do this. Okay, use the same formula, and this for this 1 2 3 4 I have written for the part B. For part C you have to write 1 2 3 4 5. Okay, B1 B2 B3 B4 B5. Okay, part C is an assignment, you have to do it. Okay, copy down the problem.